Hello everyone, I'm Evan from Biomolecular Systems, and today I just wanted to talk to you about how we have given Myra a better understanding of what's on its deck. So this isn't about replacing operators or making things more complicated, it's about adding a simple layer of awareness to help prevent common setup issues with labware. To set the scene, Myra is an automated liquid handling robot designed for everyday lab work. It handles fast, precise liquid transfers, which would otherwise be time-consuming and repetitive work for lab staff. It's also portable and compact, so it can fit easily into most lab environments. In fact, just ask the flying vet. He runs Myra entirely out of his plane and car, in the middle of outback Australia. Now we don't just stop there. Myra is also backed by artificial intelligence, giving us a smarter and more refined approach to liquid handling. One of the most common ways we see AI used in labs today is for experimental design and protocol development, often using large language models. Despite being helpful for planning, large language models can be slow and frustrating to work with. You end up going back and forth with long text prompts, fixing mistakes, and then turning that into something a robot can actually run. On top of that, large language models provide no visual checks of the labware you have placed on the deck. Our approach is deliberately vision first, which no one else in this space is currently doing. Our software is so simple to use that we don't need large language models to help us set up. Instead, we focus on saving your reagents and your money. We use computer vision models, specifically convolutional neural networks, to visually verify the labware you've placed on the deck before your run begins. We use it to check things like which plates are used, whether tips are available, and whether a cap is on a tube. With this approach, you can rely on Myra to get confidence in your results. There are no prompts to write, no instructions to interpret. Decisions are grounded in what Myra can see, which in a physical system is critical for safe and reliable operation. Also, our AI runs locally on your PC, meaning images stay on your device. There is no internet connection or the need to connect to an external server, as often required by large language models. So pipetting is more than just moving liquid from point A to B. For a human operator, it is a careful balance of vision, touch, and judgment. People rely on experience, instinctively adjusting to how a liquid behaves and where things are positioned. Myra Intelligence is our way of bringing that human awareness into Myra. Myra Intelligence is made up of 3 parts: MyraSim, MyraVision, and MyraSense. Together they allow Myra to understand what is happening, why is it happening, and how to respond. Now in this presentation, I will be focusing on MyraVision, the part of Myra Intelligence that gives Myra visual awareness of its deck. Automated liquid handling robots are incredibly good at doing exactly as they're told. The challenge is that they all assume that the deck has been set up perfectly. If something is slightly off, like slightly rotated, there's a tip missing, or plates just differently than last time, the robot won't realize until it is too late. And when that happens, you're not just making a mess. You've either turned your robot into an ineffective bottle cap opener trying to get into your master mix tube, or you're dispensing a very expensive reagent all over the deck. Be honest, when was the last time you watched a reagent you really cared about get pipetted absolutely everywhere except where you wanted it to go? Best case, you've discovered a new form of liquid braille. Worst case, you've lost over 6 months worth of sample collection in under 1 minute. Reagents are expensive. Time is irreplaceable, That is where deck awareness becomes important. So rather than relying entirely on manual checks, even with careful users, small errors naturally creep in. Deck setup is a repetitive task, and often the times you might be placing a tube slightly differently, or something might be partially used, or even a plate might be upside down. These are the kinds of details that are easy for people to miss at first glance. Barcodes, they can help with our plate-related issues, but they only work for certain plate types and need to be clean and clearly visible. Over time, barcodes, they can wear, peel, or get covered. So rather than relying entirely on manual checks, we have given Myra a powerful way to look at its own deck. We use an integrated camera which captures images of the deckwear. Then those images are automatically processed by MyraVision before your run begins. You can think of this as a lab assistant that's checking over your shoulder, except it is one that doesn't get tired or distracted. We're not replacing operators, we're simply backing them up. Here is a simple view of a convolutional neural network we use in MyraVision. So you can think of it in two parts: feature extraction and classification. Feature extraction is where the model begins to make sense of the image itself by pulling out the features that matter most. Classification is where the model decides what the image is of based upon those extracted features. Alongside this, the model tells us how confident it was in its decision. So not only do we know what the model believes the image to be, we also know how sure it is about it. Taking a deeper look into the layers responsible for feature extraction, we see that the model doesn't look at the whole image all at once. Instead, in the convolution example, we see it slides a teeny tiny filter across the image. This filter responds to simple visual patterns like edges, curves, and texture. The result is a blue feature map, and this highlights the positions of these patterns. We then use pooling to reduce these feature maps down to retain features that matter most and disregard the ones that don't. This allows the model to be more tolerant against slight changes in both lighting and placement. And it's when we stack the convolution and pooling layers together do those simple features start turning into more meaningful patterns, like the outline of a plate, the spacing of wells, and even the shape of a tube. It's after a predetermined amount of stacked layers is the model able to build up its own internal representation of what it believes the image to be, allowing it to make confident classifications. So here we see the full journey from image capture to making a decision. First, Myra captures an image of the deckwear. It then identifies what this image is of and compares that to against what the run expects. Based upon this comparison, Myra will either allow your run to proceed or it will flag an issue to the user. Now, I'd just like to highlight that this whole process is done in just a click of a button. We focused on three areas where common setup issues most often occur: across plates, tubes, and tips. Although these tasks sound simple, they cover a huge amount of real-world variation, including differences in lighting, varying colored liquids, and slight changes in placement. To handle this, we have collected a large data set over time. So across these three classification tasks, we've collected nearly 500,000 real images captured across multiple Myra robots. That scale matters, because it reflects how these systems are used day to day, not just in ideal or staged conditions. We've also developed a simple support system for our users. So if a misclassification were to occur, it can be flagged and added to our data set, helping MyraVision become smarter and more accurate over time. So plate classification is about making sure Myra is working with the correct plate. We support over 20 different plate types, from simple loading blocks up to higher density formats like your 384 well and even a 1536 well plate. The challenge we face is that once these plates are placed onto the deck, they can look very similar. A 384 round well plate and a 384 square well plate might sound interchangeable, but they're actually used for very different tasks, and using the wrong one can have a big impact on the accuracy of your run. In this example, we see a user has told Myra they have placed a 384 square well plate onto the deck. MyraVision has identified this as a 384 round well plate and has notified that back to the user. Now, this is the level of accuracy we need, especially when handling more complex plates. Tube classification is about making sure Myra is interacting with the right tube type. We support over 10 different tube formats, from small 0.1mm PCR tubes up to larger 15mm reagent bottles. Now, we don't just care about size. Myra also identifies whether the tube has a screw cap or a flip cap, and whether or not if that cap is on or off. This helps reduce things like failed aspirations or physical collisions that may occur during a run. In this example, we see Myra is looking at a variety of tubes with their caps on and off. Bringing our focus towards the highlighted tube, we see MyraVision has identified this as a screw cap tube. It's just notified to the user that they need to remove the cap before continuing. Tip-related issues are a common cause of mid-run failures. Before your run begins, Myra will automatically scan your tip rack and identify whether it is full, partially used, or empty. That information is then pre-selected within our Workbench software, so users don't have to manually specify how many tips they've got left. This saves setup time and ensures that there are enough tips available before your run begins, rather than finding out halfway through. Now, a great example of this comes from one of our customers who operate in a shared university lab. So students have to bring in their own tip racks to use with Myra. And before MyraVision, students had to manually configure their tip racks to match what they had brought in. And most of the time, these tip racks that they did bring in were partially used. Now, they just click one button and Myra will do it all for them. So we treat plates, tubes, and tips as three separate tasks because they are very different kinds of objects. Plates, they're flat, rectangular, and often defined by their well layout. Tubes, they can be capped or uncapped. They're cylindrical and can change in appearance depending on the angle and lighting. Tips, they introduce their own kind of variability. So because of all this, the mistakes you can make with each are different. So by treating them separately, the model can focus on the features that matter most. And when an issue is flagged, it makes it much clearer to the user what went wrong. One of the biggest lessons we have learned when building MyraVision is just how much the small visual details matter. Even the same tube type can vary, with text printed atop its cap, or being an entirely different color. Now, these simple visual details can confuse vision systems. Another key lesson is the importance of clear feedback. If an issue is flagged, a user needs to understand why. That transparency builds trust in MyraVision. We've designed MyraVision around how labs operate. We've trained it on real images captured across multiple Myra robots, including everyday variations with differences in lighting, varying colored liquids, partially used tip racks, and slight changes in placement. By learning from these real-world conditions, Myra can focus on the features that matter most and ignore the ones that don't. The goal here is reliability. We don't need Myra to be smart in a human sense. We just needed to consistently detect when something is wrong. Oh, did I say it was fast? Like really fast. A single image takes less than 3 milliseconds to classify, meaning potential issues are flagged almost instantly. So at this point, you might be wondering how MyraVision fits into your workflow. Before your run begins, Myra captures images of the deckwear and confirms that against what the run expects. In a moment, I'll show you a short video of this happening in real time. You'll see Myra scan the deck, identify what is present, and either allow the run to proceed or flag an issue to the user. The key takeaway from all of this is that it happens before any liquid handling begins, when problems are easy to fix. So for this demo, I've set up a simple water transfer run within our Workbench software. Upon starting the run, users will be presented with a pre-run validation checklist. Once complete, Myra will begin its homing procedure and continue on with the deck scan. So here we see it scanning the tip rack, and what is happening is that it's identifying the presence of a tip within each well of the rack. As the scan is happening, users will be provided with the progress and outcome of each scan. As the scans come to a complete, Myra will show us what didn't match expectations. So here we see it's identified the partially used tip rack and it has been selected for your convenience. Hovering over to our other issues, we see that it's identified a screw cap bottle that still has its cap on. And on our right, it's identified a plate that is missing from its socket. So before rerunning the scan, we want to go ahead and address these issues. We take the cap off the bottle, and we move the plate to its correct socket. We can now rerun the scan, so Myra will go through and re-verify everything visually. Hopefully this time we start to see green ticks above all our labware, which signifies that Myra has matched its expectations. And that we do. So you can now start your run with confidence. So we see MyraVision as a foundation and not a finished solution. There will always be new plate types and tube formats entering labs, so we're continually expanding on what Myra can recognize. We also know how fiddly it can be when trying to manually calibrate labware for use with an automated liquid handler, especially when you need to be pixel accurate. Even when you're using the same plate type, things aren't always identical. A plate's calibration position can vary slightly from plate to plate. That is why we're adding a new exciting feature: automatic plate calibration. Myra can now automatically calibrate itself to a plate's calibration well and verify this position before your run begins, ensuring perfect performance every time. Since the release of MyraVision, we've noticed a real difference in day-to-day lab work. Runs are failing less often because issues like missing plates, empty tip racks, caps on tubes, it's all caught early, saving you time, money, and a lot of frustration. Setup is faster too. Users don't have to triple check everything or manually configure their tip racks. MyraVision already knows what's on deck. Another key benefit is confidence. Users can now focus on their experiment rather than spend time worrying about whether Myra will behave as expected. Thank you for having me. That was MyraVision. Start your run with confidence.